Hey everyone, so today we are going to learn how to solve for systems of equations by using the elimination method. And so I know that when we eliminate something, that kind of means to get rid of it. We've done a lot of eliminating in math, like let's say if I have x minus 2 equals 3, I would know to eliminate that 2 by doing the opposite operation. And so that's what this entire method really focuses on, eliminating by using the opposite operation. So the definition of elimination method is a method of solving systems by adding or subtracting, and that's my opposite operation there, to eliminate a variable. So in its most basic form, we eliminated this negative 2 by doing the opposite operation, and that's gone. So that's what the entire elimination method focuses on. So in order to do that, step 1, I would want to make sure the equations are lined up. So looking at number 1, I see the y is lined up with the y, the x term is lined up with the x term, and then I have numbers over here. So in number 1, they're already lined up, but of course when we move on to more difficult problems, we'll need to do that ourselves. Step 2 would be to add or subtract the equations to eliminate the variable with common coefficients. So that's what's going to be important here. Looking back up here with my 2 example, maybe I would say this was negative 2y and positive 2y. I could do the opposite operation and I would cancel out that entire 2y term, and that is going to be our goal here. Step 3, I would solve for the remaining variable. We'll see what that means. And then my last step would be to substitute your answer into either original equation, because I have 2, both of them would work, and solve for the other variable. Okay, so let's go ahead and follow these steps and see them in play. So step 1 says make sure the equations are lined up. In number 1, we already kind of went over that. I'm going to add or subtract the equations to eliminate the variable with a common coefficient. So in looking at number 1, I do see that my y terms have the same coefficient. Technically, they both have a coefficient of 1. Now, we know that this doesn't cancel each other out, right? Like if I said 1y and 1y, that's 2y. Back up here, we said in order to really cancel it out, I have to have opposite operations. So what I can actually do is take this entire second equation and I'm going to multiply it by negative 1. That way now this is negative y, negative x, and that negative 2 turns into a positive 2. Because remember, I can do whatever I want to an equation as long as I do it to both sides. So if I make that y a negative, I need to multiply the other side by a negative 1 as well, changing the sign for everything. So that's what I did to the second one, and there was a reason I did that. I'm going to rewrite my first equation I had up at the top. Oops, plus. And so now I can see that I have a y minus a y. Because these are opposite operations with the same coefficient, I can just cancel these out. And technically, what that leaves me with on the left side is 0. I can further combine my x terms, 3x minus x would give me 2x, and then 4 and 2 would give me 6. So what I'm doing is adding these two equations together. Notice how the y term is completely canceled out. Nothing is left. And so all I have left is x. If all I have left is x, I can isolate my x and solve. So, in order to isolate x, I might subtract 6 from both sides. So the rest is just all about solving. We already kind of did the hard part. And then I would divide both sides by 2, and we get that x equals -3. Okay, so that's the only real new part. But remember, a system of equations not only has an x coordinate, but also a y coordinate. So now that I know what x is, I can do step 4. I can substitute my answer, x equals -3, into either of the original equations. And so it doesn't matter. I always just pick the one that I feel like looks the easiest. So I'm going to rewrite one of my original equations over here. And now that I know x equals -3, I can substitute in -3 for x. The rest is super simple math, because then I can figure out that if x is -3, y has to be -5. So my actual solution, I would take my x, I would take my y, and my solution would be -3, -5. That would be my actual answer. So again, elimination method is basically using the idea of opposite operations to cancel out an entire variable. In this case, I canceled out the entire y, and then I was able to solve for x. Once I solve for x, then I can plug it back in and solve for y. I know it seems like a lot, it's a little overwhelming, but the more that we practice it, the easier it'll get. So looking at number 2, step 1 says make sure the equations are all lined up. They're not in slope-intercept form like the first one, but my x's are lined up, my y's are lined up, and equals, and then my numbers. So they are all lined up in standard form, but they are. So hopefully we're starting to maybe kind of see already what I can change here. I see 2 common variables with a common coefficient. In this case, I have x and x. So I know that if I'm using elimination method, I have to eliminate one by doing the opposite operation. It doesn't matter which one you choose to multiply by -1. I'm actually going to pick the second one though, because I see that there's a negative here already, and maybe I can like get rid of it. I don't know. So that's going to turn that positive x into negative x, that negative y into positive y, and then that positive 3 is now going to be -3. So I just changed one of them. That's all I needed to do. Whatever I do to one side, I do to the other. I can do whatever I want. So then I'm going to rewrite this original equation that I had, and I'm going to start eliminating some things. So my x terms are eliminated. 4y and another y would give me 5y. That equal sign stays there, and then 13 minus 3 is 10. Like, we can see how easy this is after we do it a couple of times. We're like, oh shoot, y is just 2. That was super easy. That only took a couple of steps. Now that I know that y is 2, I can plug it in whatever equation I want. I'm going to pick the one that looks the easiest for me. That would be this one. I'll rewrite it over here and plug in that y value of 2. So x minus y equals 3. Isolate that x by doing the opposite operation, and I have x equals 5. So I'm going to take my y, my x, and write my solution, making sure that my x comes first, and then my y coordinate. Super simple, just takes a little bit of practice, but it's really nice that our whole goal here is like canceling out an entire variable. That's less work for me. So I'm going to hop around just because I want to do at least an example of each with you. None of them get too difficult though. So let's jump to, let's just do number 6, I guess. I don't know. I'm looking at ones that you might have trouble with on your own, I suppose. All right, so looking at number 6, we can clearly see that I already have these lined up, and I can see that I have a y variable that already has a coefficient of -3 and +3. So like, that's super easy. I don't even have to do any work. I can already jump to combining them because these 3's already cancel out. So 10x minus 2x would just give me 8x. And then 18 and 6 would just give me 24. So elimination really just ends up giving us a lot of times a one-step equation that's super simple to solve for, and then all I have to do is use that answer and plug it back in. This one's not as easy, so I don't know, I'll just pick this one. Now that I know x is 3, I can plug in x, and then that means all I would have left to solve for is y. -2 times 3 is -6. So I would end up adding 6 to both sides. We've already been basically using elimination method, leaving me 3y equals 12, and then isolating to solve that y, which is 4. I'm going to take my x and my y and write my single solution. So today we're basically just focusing on equations that already have common coefficients. So for example, like these are already common coefficients. These are already common coefficients. You can look at them and identify right away which variables are common and have common coefficients. Tomorrow, we'll focus on elimination method when our coefficients aren't common already. So I'm going to have to add an extra step in there. So get comfortable with this today, because tomorrow we're taking it a step further. So I want to do maybe 3 more examples with you. Let's see. That means I would have done 6 with you. All right. So I want to jump to number 8, because looking at number 8, I can already tell that one of my equal signs is over here and one of them is over here. So they're not lined up. Yes, my x's come first. Yes, my y's come second. And then my numbers are at the end, but that equal sign throws it off. Everything needs to be lined up. So I see that my x is by itself here. My 3 is negative here anyways. So I'm going to add 3y to both sides, making this equation now 2x equals, because that's gone on that side, 3y plus 16. I'm going to rewrite that original first equation that I had, and now I have everything lining up. My x's line up, my equal sign lines up, my y's, and my numbers. But I need the opposite operation in order to use elimination. So I'm going to have another step here. Step 1 was making sure everything was lined up. Step 2 then is making sure I have opposite operations. So again, it doesn't matter which one you change, but I guess since I already changed the second one, I guess I'll change the first one just because. So now I have negative x equals negative 3y minus 11. You could have changed that second one to make everything negative there too. It doesn't necessarily matter which one you choose. And then I'll rewrite that second one. I'm going to go to kind of combine all of these together. Negative 1x plus 2 would just give me 1x. Look at that, x is already isolated. That actually worked out nicely. Negative 3 plus 3 is just 0, so that's gone, cancels out. And then negative 11 plus 16 is 5. Look at that was super simple. So I have that x equals 5. Be careful, you're not done yet. Remember, for a solution, I need an x and a y. You can pick any equation you want, because all of these are true. This one is true, this one is true, this, they all work. I promise you, if you plug in 5 to each and every single one of those, your y would be the same. I guess I'll pick this one. It really doesn't matter. So I'm going to rewrite that first equation that I said I'm going to pick. And since I know that that x equals 5, I'm going to plug that in for x and solve for everything else. So I want to isolate that y. I'm going to get my numbers all on this side. That would give me negative 6 equals 3y. To isolate that y, I want to get rid of that 3. Y equals negative 2. I'm going to take my x, take my y, and write it as a nice coordinate point, because that's how we write our solution to a system. So far, we've done 4 examples together. I want to do 2 more because I want you to see what a no solution and infinite solution would look like. And they're very, very simple. They're actually easier than all the ones that we've done. I just want to make sure you see it. Because so far I've gotten 1 solution, 1 solution, 1 solution, 1 solution. So our none and infinite solutions are actually going to be number 10 and 11. We can tell that something looks different with number 10. It's like it's almost the same, but like not really. So let's actually work it out and see what happens. I could really choose to cancel out my 3s or my 4s, but either way, I have to change my sign. So this becomes negative 3x plus 4y equals positive 10. I changed the sign of all of them, and I'm going to rewrite that second one that I had. So in a no solution system, you'll end up seeing that my x's cancel out. Negative 3 plus 3 is 0. That's gone. And also, my y's cancel out. So really what I end up with on the left is 0. On the right side, 10 minus 13 is negative 3. 0 equals negative 3. This is an untrue statement. Whenever you end up with an untrue statement, you can say there is no solution, or you can write that symbol. So super easy because you really didn't have to do too much math. You see that everything cancels out right away. You can't even really solve for anything because we're just left with an untrue statement. Nothing that we can really do something with. So a no solution, you end up going through the motions, but you end up with an untrue statement. So for number 11, my first step would be to make sure everything is lined up, which they're not. I have my X's and it's all jumbled up. So I'm actually going to, this one's already in slope-intercept form, so I'll actually change the first one to slope-intercept form. In order to do that, we would get rid of this X term, right? So all I'm left with is y equals, and then I can't combine those together, so I would just rewrite them. We've been working on standard form to slope-intercept form a lot. And then I'm just going to rewrite boop, 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 boop. And so kind of similarly, and when I end up with a no solution, when I go to work out an infinite solution, I see that these cancel out similarly to like they did with the or with the no solutions. So I end up with 0, just like we did up here. And these also cancel out, -2 plus 2. And then my numbers also cancel out. -10 plus 10 is 0. So I end up with 0 equals 0, which is always true. It might not always be 0 equals 0. It could be like 5 equals 5 or something like that. Depends how you line it up. But if I end up with a statement that's always true, there's no variables, there's no changing it, that would be infinite solutions. Okay. So you've seen multiple examples of one solution. You've seen an example of none and infinite solutions. What I would like for you to do is finish the rest on your own. So that would be numbers 3, 4, 7, and 9. Right. Oh, and 5. Hello. So on your own, you're working on 3, 4, 5, 7, and 9. That's 5 problems. And so you probably have about 20 minutes left of our class. So you should be able to finish those. You're more than welcome to do those on your own because I will be checking them in your OneNote. If you would like to hop into my Zoom room, I'll be sitting there waiting to help anybody that needs it. But feel free to just kind of work on your own for the rest of our class time.